Hello. We're going to graph y equals the sine of x on this oddly shaped Cartesian coordinate system here. And I did this on purpose, extending this line out because that's how this sine wave is going to kind of start and end out through here. So we're going to call this axis, let's make it red, theta. Let me get my marker. Sorry about that. Theta radians, and we'll call this axis here the sine of theta. Okay, the sine of theta. So the x-axis will be in radians, theta radians, and the sine of theta will be this axis here. So what we're going to do is graph y equals the sine of theta. And I know I briefly went over this yesterday, but here it is officially. What we're going to do is make ourselves a little XY type table. But instead of going X, Y like this, I am going to do theta sine theta. And I'm going to make a table going right down through here like this. Make me some nice marks. Across here, making this table look really nice. That one didn't look so nice. You get the idea. There we go. So we're going to fill this in with just some things from the unit circle. The what? That's right, the unit circle. So let's look at the unit circle because it definitely has ties into this, believe it or not. So here is our unit circle. And we remember that this radius here is, of course, 1, and this distance all the way around here. So we can call this point right here, this pink point, 1, 0. We call this crucial pink point 0, 1. This one will be negative 1, 0. And this one will be 0, negative 1, because it's all 1 unit away. Okay, that length right there is 1 unit away. Alrighty then. We also need to remember, so I will overlay this with green, that this is, of course, 0 here. This is the starting point, and as this starts to go up through here like that, a lot of dots to erase there. As this starts to go up and start going around in circles here, that's going to generate lots of coordinates down this graph. So let me show you how that all works. This would be, of course, pi over 2, which would be 90 degrees. Remember, if you wanted to figure that out, you could take 90 and multiply it by pi over 180, and it would turn that into that. This would be pi. This would be 3 pi over 2. And this would, of course, be, if we did a full lap, would be equal to 2 pi, and then so on. You could keep spinning this, and in fact, the sine wave does keep spinning. Alrighty then. I'm going to label these green coordinates down this graph here. So we'll start with 0, and we'll have pi over 2, and of course, pi. I'm just doing every fourth of these pink dots here, or the green pi symbol, the radians measurements. 3 pi over 2, and of course 2 pi, which will be equal to 0. Alright, now, the other thing to remember is the coordinates. The coordinates, these pink numbers here, this 1, 0, we remember that being equal to the cosine of theta, sine of theta. And if you don't remember that, let me take you on a little mental journey here back in time to just show you that one more time. So I'll make a quick little diagram of this. So let's say here's our right triangle. Okay, and this would equal 1, and this would be x, and this would be y. I know, it's awesome. That is a right triangle there. And we remember that sine is, of course, opposite over hypotenuse, which would be of that angle right there, the sine of theta, I should be saying. is y over 1. And the cosine of theta, which is adjacent over hypotenuse, would be x over 1. So that's x, and this is y. And those are all equal signs. So we can say, therefore, the sine of theta equals y, and the cosine of theta equals x. So the xy coordinate, that's these xy's, would be cosine theta sine theta. You just got to know that. You got to be able to do that. All right, so now back to our, of course that would jump out like that. I don't know why it does that when I start recording, but whatever. Okay. So this is true. The cosine of theta, sine theta. That means that these values here of the sine are just going to be the y values of these points. I'm going to circle them in red, and then I'm getting rid of it because it's going to clutter up everything. But at these points, 0, pi over 2, pi, 3 pi over 2, and 2 pi, that's here, 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 and then back to here, are just going to be these values here. 0, 1, 0, negative 1, and then back to 0. So I can fill these out. Now I'm going to, like I said, I'm going to erase those circles. But that's going to be 0, 1, 0, negative 1, 0. And you can see how I filled that out is based off these pink numbers, the y values of these pink numbers. And then if I come over here and graph this, 0.00 would be here. Okay, that's 0, 0. And then I'm going to section this off, pi over 2, pi, 3 pi over 2, and of course 2 pi. And that's going to, the next xy coordinate, I guess, would be pi over 2, 1. So I would have to go up 1 here. So that would be right there. The next one would be pi and 0. So that would be here. 3 pi over 2, negative 1. So we'll go down to negative 1. So that would be right there. And then back to 0 here. So if I can get this, it's going to go like this, and then down, and then back up like so. And that is one wavelength, or what's called one period. Period. There's lots of different things we're going to talk about later, but that's basically it. If you kept going with this down through here, this is going to, of course, keep repeating like that. And it's also going to do the exact same thing and behave the exact same way over here. And that's going to keep going forever like that. And there you go. That is the graph of a sine wave. Talk to you later.